right, so for this section, we're going to be talking about product of powers property. And there's two main things that we're going to talk about. One, multiplying powers with the same base. When you do that, basically all you're going to do is add the exponents. All right, that's it. Now, what in the world did I just say? Let's go ahead and give you an example. Let's say I have 2 to the third and I am multiplying that by 2 to the fourth. All right, now, what this is really saying is 2 times 2 times 2 for this part, okay? And it's multiplying it by 2 times 2 times 2 times 2, which is this part. So what do I have here? I have 1, 2, 3, 4, 5, 6, 7. I have 7 2's being multiplied. Well, that I can rewrite that knowing from our last video, when I multiply a number by itself so many times, I can just simply say to the 7th. Well, I didn't have to do all this work to prove this. I could have simply said, wait a minute, hey, this is a 2 and this base is a 2, so my final answer is going to have a base of also a 2. And then these exponents right here, I can simply just add them. And that gives me 2 to the 7th. All right, and I just saved myself a lot of work. So let's just give you one more example. What if I had 15 to the 6th times 15 to the, I don't know. Let's make up something here, 4. All right, now well, the bases are the same, so I'm gonna write the same base. And since I know these two are the same bases, I'm just going to add my exponents. So my answer would be 15 to the 10th power. That's it. All right, so the next piece, it says raising a power to a power. It's basically repeated multiplication. What am I talking about? Let's give you a very simple example. Let's say I had 2 to the third, and I'm going to raise that to the 2nd power. All right? Well, when I write this, I can say 2 to the third times 2 to the third. Okay? Wait a minute, since I've done that, why did I do that? Well, I know I'm multiplying 2 to the third 2 times, so that's why I did that. And this follows the same rules. Hey, since I'm multiplying and it's the same base, I'm simply going to add these exponents. The base is a 2, and 3 plus 3 is 6. All right? That's all it is repeated multiplication. Let me give you another one. Let's say I have 4 to the 8th, and I want to move that to the 3 times. Well, I can say 4 to the 8th times 4 to the 8th times 4 to the 8th. Well, what's my base? 4. So I'm going to write it down. What are my exponents? I have 3 of them, so that's 8 plus 8 is 16, plus 8 again is 24. So my answer to this is 4 to the 24th power. However, I'm lazy. I don't want to have to write all this out every time I'm raising an exponent to a power. So I'm going to multiply the exponents. Huh? What are you talking about, Mr. Lewis? Let's explain this. Use this exact same example. 2 to the third raised to the 2nd power. I'm going to actually multiply these two numbers. I'm going to multiply my exponents. What is 3 times 2? Well, 3 times 2 is 6, and my base is 2. Hey, that's the exact same answer I got a while ago. Just save myself a lot of time. Let's do the next one. I have 4 to the 8th, and I'm raising it to the 3rd power. Well, what's my base? My base is 4. I'm lazy, so I don't feel like writing all this out, so I'm just going to say, what's 8 times 3? Well, guess what? It's 24. So 4 to the 24th power. This is the quick way of multiplying exponents and raising a power to a power. Just multiply. So just a quick little review. No, never mind. Let's move on. Let's go to some more problems here. So here we got -6 to the 5th times -6 to the 4th. What's my common base? Well, it's -6 in parentheses. Since this is multiplication, it means I'm going to take these two exponents and add. What's 5 plus 4? 9. I'm done. What about this one? I have x to the 1st times x to the 9th. Well, what's my common base? X. What am I going to do with these numbers right here? I'm going to add them, so I have x to the 10th. I'm done. All right, so let's do this one. All right, so this says y to the 10th, and it's being raised to the 20th power. Well, I know that my base is y, so I'm going to write it down. And since this is an exponent being raised by an exponent, that means I'm going to say 10 times 20. Well, what's 10 times 20? We do a little bit of math over here to the side, just a little bit. Well, that gives me 0 all the way. I'll hold my place value. This gives me 0. This gives me a 2, so that gives me 200. So this is y to the 200th of a power. All right, so why don't you try 3, 4, and 6 on your own? All right, so for number 3, you should notice that your common base in both of these is 4/5, and since I'm multiplying it, I'm just going to add the exponents to get 4/5 all to the 15th power. My common base in number 4 was negative 1.5, and that's in parentheses, and since it's multiplication, I'm just going to go ahead and add these exponents to get 22. And then for number 6, if you notice this is negative 2/9 to the 8th power, all of this being raised to the 7th power. So my common base in this case was the negative 2/9, which would have been here. And then I would have multiplied the 8 and the 7 because this is a power being raised to a power. So 8 times 7 is 56. All right, so number 7, it says simplify the expression. Now this is where a lot of people get confused, and we're going to try to break this down step by step. This says 2a in parentheses raised to the 6th power. What it's saying is everything that's inside this parentheses is being raised to the 6th power. And this 6 not only affects the 2, but it also affects the a. So we can rewrite this as 2 to the 6th power and a to the 6th power, because this 6 is affecting both the 2 and the a, this variable. Now that we've done that, we can do a little bit of math, and hey, I'm a little lazy right now. I'm going to use my calculator. Hey, I'm letting you use it. 2 to the 6. Well, I could do this by hand, 2 times 2 times 2, but this time I want to do it with a calculator. I'm going to put 2, which is my base, and then I'm going to look for this little button. Looks like this little house top, okay? I'm going to call this my raise the roof button because we're going to raise this 2 to a power. So we're going to raise to the power of 6 by pressing this button, raise the roof to the 6th power. All right? When I do, hit enter, and I find out that this guy is 64. So this would be 64a to the 6th power because I cannot do anything else with this. Now let's look at the next one. Let's try, I'll work 9 with you too. So let's do 8. Now this 4 is affecting everything on the parentheses, inside the parentheses. And because it's affecting everything, it's affecting the negative 4, and that's being raised to the 4th power. And it's affecting the b, that variable is also being raised to the 4th power. So this is what I've gotten so far because it's affecting the negative 4 and the b. These are two separate entities, and we can treat them as such. Now that we've done this, what's negative 4 to the power of 4? Now your instinct probably would be to do this, negative 4 to the power of 4. Okay, negative 4, raise the roof button to the power of 4, and then hit enter. And then you would get negative 256. That might be your instinct right now to do that in your calculator. And if you did do that, it's wrong. Why is it wrong? I want you to look at your calculator. You remember what I told you is that when we raise a negative number to the 4 to a power, this only affects the number and not the negative. But look at our problem. In this case, it's affecting the negative as well. So when we have to put this in a calculator, we have to put it in with parentheses. Parentheses, negative 4, close your parentheses off, raise the roof, and we're raising it to 4. Okay? And now we can hit enter, and when we do, we get 256. B to the 4th. This is your correct number because the negative is being affected by this exponent. All right, let's work 9 out because this has got a fraction. It looks terrifying, doesn't it? Well, let's work it out. This square, this second power is affecting both pieces. It's saying negative 10, and since that was in parentheses, it's affecting the whole piece, and it's also affecting the p square. So what's happening here? Well, this looks terrifying, but guess what? It's not if you look at it from another perspective. Let's concentrate just on the side. I'm going to rewrite this as negative 9 over 10 square. All right, we're going to write it out to the side. All right, what you need to understand is this square is not affecting 9. It's affecting, let me see. After you write it, what you need to understand is this square is affecting the negative 9 and the 10. So we can rewrite this as such. Negative 9 square over 10 square. All right? It's another way of writing it. Well, negative 9 square is pretty easy. That's going to give me a positive 81. 10 square is going to give me 100. And then p square is left by itself. Now, what you need to realize is, yes, this is a fraction, but you can treat it as two distinct numbers. You can square the numerator and you square the denominator. And when you do, you get 81 over 100 and p squared. So you have to realize that each individual piece is being squared. The 9 gets squared, or the negative 9 gets squared, the positive 10 gets squared, and the p gets squared, each individual piece. So why don't you try 10 through 12 on your own? All right, 10 is pretty easy. This 15 is affecting the x and the y, so we can write it as x 15th, y to the 15th. Number 11 was a little bit more difficult. This case, it would be 0. Why? Let's talk about it. Lest you remember, please excuse my dear Aunt Sally. All right, so let's talk about that. Please, parentheses, well, can't do anything here. Excuse exponents. Hey, check this out. I have 10 to the 1 and being raised to a power. So because this 1 is being raised to the power of 8, I can rewrite this as 10 to the 5th times 10 to the 3rd minus 10 to the 8th. Okay? Now, so we've done our exponents. Now we're going to do multiplication and division. Well, these two are being multiplied, and since these have the same base of 10 and they're being multiplied, the exponent is being added. 5 plus 3 is 8. Now I have 10 to the 8th minus 10 to the 8th. Well, we can try to use a calculator on this and we would get our answer, but what's the point? Notice, this is a number, 10 to the 8th. It's a number being subtracted by itself, 10 to the 8th. Well, what happens when you subtract a number by itself? You get 0. 1 minus 1 is 0. 2 minus 2 is 0. 3 minus 3 is 0. So 10 to the 8th minus 10 to the 8th is 0. Now, this one may have stumped you, so I would have accepted either or of these answers because it didn't really clarify what I mean by simplify. To me, this is easier than this, but so if you answered either or, it's fine. But if we work through it, we work for parentheses, so we go inside the parentheses. We notice these two are being multiplied. They have the same base value, so we put 7 down. Since they're being multiplied, we just go ahead and add our exponents. 4 and 4 make 8. So now I have 7 squared times 7 to the 8th. And since these are multiplication again, and they have the same bases, I write 7 down as my base, and my exponents gets added to 10th. And so my answer would have been 7 to the 10th, and what I did is I put it in the calculator, and I got this really, really long number. So this is 282,475,249. 249. All right, so 13 says the surface area of the sun is about 4 times 3.141 times 7 times 10 to the 5th, all of this piece being square kilometers. Simplify the expression. Well, you know what? I think I'm going to give this one to you as a challenge problem. I was about to work it out for you, but you know what? I'm going to give this to you as a challenge problem. You can work this one out. Can you do this one on the calculator? Let me see. Yeah, this one right here, you really cannot work on a calculator to get an exact number, but give it a try. See what you can do. This one goes into something that we call scientific notation, but I think you can try this one. All right, and I'll see you in the next video. Bye-bye.